So welcome again. So in this session we are going to talk about the evolution of computing. That is all about that how the technology has evolved up to the present time. So let's start. So we have witnessed the era of inventions. We have witnessed the age of printing press. We have seen the growth in the steam engine. Then we have the age of electricity, the transportation age, and then we move with the invention of computers. And now we are talking about the cloud technology. So let's see one by one that how it is actually evolved that bring us to the current stage. So with the invention of the printing press, it actually gave us everyone to access the book. We are talking or preparing about the encyclopedia. When there's an invention of a steam engine that gave us the efficiency of the cars, the trains have been come into existence, and that actually transformed the transportation industry, that allows the business to produce and transport the goods at a large scale. Then we have come into the picture electricity. That's a very important invention that we have in the present time. So electricity brought us the light bulb. We are going to use household appliances, or you can say electrical appliances, and with that eventually we come out with the computer. Now if you think about the era of electricity, in the initial year you can find that most of the generators are found where the peoples are living or working. Now just try to make a context with the present time. So as the industry become more mature, then we created a power plants. So power plants will be developed, which allows us to access the electricity through the grid. In the same time, or you can say in the same way, these principles apply to the current scenario, or you can say in the scenario of cloud computing. Here we are generating a huge data that is to be kept at a data center, and this data can be accessed through a grid. So grid is actually here is internet. So we are creating, or kind of designing or getting this huge volume amount of data from the social media to the embedded systems, to the sensors, to the IoT. So all these devices or the systems are creating the huge amount of data that can be managed and stored at the clouds, and we have the provision to make use of data through the different techniques that is available with the cloud computing. So now we have lots of data, and we are also having a technique to store and manage it and to use it efficiently with the help of this cloud computing. We will see that how it is possible. But cloud computing is not only allowing us to store this huge amount of data, but it will also make us possible to use smartly or intelligently to make some predictions or some smart analysis that can grow our business. So let's talk about the evolution in the cloud computing. So we have seen that how the technology has advances with the printing press to steam engine, then to electricity, and then to our today's computers. But when we talk about the evolution in the cloud computing itself, then also we have seen a different framework that have been used in the past days, and the framework has now changed that we are using in the current time. So we have seen that there is a huge change in the architecture, the way we are using the computer. So initially, when the computers were actually coming into the picture, then we are thinking about how to utilize these computers in a better way, and we think about connecting these computers, and then the internet was proposed. So initially the idea was actually only to apply this to the military purposes, where we want to use the resources and want to connect together. But then with a lot of advancements, we have realized that this importance or this important utility can be provided to all the consumers, and then internet has been open to everyone. Then we have realized, because we want to utilize the resources, we want to share the resources, and then we have started with the centralized computing. So initially the idea was why to duplicate the data in different machines, whether to it's better to create or to store the entire data in one machine, and then entire thing can be shared with all the users. So we come up with the centralized computing architecture or the framework, where we are actually having a client server model, where we have one server which is actually a huge machine that actually stores and processes all the data which is required to run the business, and then we have a client which are actually the user of this data. So this is the framework that we have been using in the earlier days. But then we have some issues are there. We have some issues. We have some problems with the centralized computing that you will see in the next slide. Then to overcome these shortcomings of centralized computing, we move to the distributed computing, which is some advantage over centralized computing and also able to address the shortcomings of centralized computing. And then we have extended the framework of distributed computing that give us the cloud computing. So many times you come across that distributed computing and cloud computing are used interchangeably, but they have a technical difference. So we will try to understand what is the technical difference between the two. So let's start to understand first what is centralized computing and how it works. So we know that invention is basically happening because whenever we realize any need, whenever we find that the current system is having some fault, then always we go for a betterment, and this betterment comes up with new invention. So when the centralized computing system were earlier proposed, so in the centralized computing system, this is basically a system where we have one large computer and we are calling this as a server, and server is controlling all the data and manages the complex computation. So apart from this benefit of the centralized computing system, if we look to the entire scenario and if we look to the context of the present requirement, we will find that there are certain limitations of this system. The capacity of the server is limited. So though we are going to create one very large machine with a very huge processing capability, a huge amount of RAM and a huge amount of hard disk, or the storage capacity we provide to the server, even then it has a limit. We cannot say that this is a infinite machine and can handle the infinite traffic. In the present scenario, the entire things are connected all over the world through the internet, and we are generating a huge amount of data every second, and to process this huge amount of data is beyond the scope of the one machine, or you can say one server. So this server cannot process huge volume of transactional data. This is one limitation. And the other limitation or a drawback of this architecture is this is a central architecture. That means we have one server which is a central machine, which is a key operative machine, and if something goes wrong with this machine, then the entire system will be collapsed. So this is a huge drawback. So this server becomes a bottleneck. So if there is something wrong with the server, then the entire system will be going to collapse, and all your business transactions will be going to fail. So this is a big limitation. We are dependent on one machine, so we need to come out of this so that the business will always be running. So we always want the availability and reliability with these machines. When we want to bring all our business on the machine, then only it has a meaning. So these are some drawbacks which are actually a source to move to the distributed architecture. So we'll move to the distributed architecture. So let us understand what is a distributed architecture or a distributed computing. We also call it as a distributed systems. So distributed systems are basically a collection of independent computers which actually works in collaboration in such a way that a user feels that he is interacting with a single coherent system instead of multiple computers. So although there are multiple machines, they are working together, we are calling it a cluster, but the user of the distributed computing, he always feels that he is he is interacting with a single coherent system. Now when I say coherent system, so coherent system is a computer system model in which two or more processors or core, you can say, share a common area of memory. So these computers which are a part of the system, they actually communicate with each other by using the interconnected work. Now, what is the basic feature of this distributed computing? So the distributed feature, the key features of this kind of computing or this kind of architecture is, we actually know that any problem comprises of multiple tasks. So whenever we are going to solve any problem, and the problem will be consisting of multiple tasks. So instead of allotting this problem to one processor, we are solving parallelly all these multiple tasks, so that as a whole we are able to solve this problem parallelly and in a better way and in a faster way. So what we are doing is these tasks which is comprising the problem, each task is actually to be processed by individual computer of the system. And these individual computers or the systems are having they are actually complete in itself. They are having their own memory, they are having their own processing power, so they are working to solve the task. So they work together to achieve a common objective, means they work together to solve these small tasks, to solve actually the big problem of these tasks are a part of. So if you want to understand what exactly is the distributed computing, and if you want to feel that what exactly is architecture, what are its components, then the Kafka architecture is a purely distributed computing architecture. It's a distributed architecture and it's very, very popular. So we will also see that what exactly is Kafka architecture. So you need to remember this name, that Kafka architecture is one of the is a perfect example of distributed systems. So let us look about the key points of distributed architecture. So we can see here that one application can be executed on many machines, or a machine can run many applications. This is a beauty, because actually here we are assigning this task to a cluster, and the cluster is comprising of many machines. So cluster is basically it's a group of machines that are virtually or you can say they are geographically separated, but can work together to provide the same service or application to the clients. So the cluster basically consists of many machines and also can contain many applications. Now adding the power to the cluster, basically we are adding more nodes to this. So cluster is basically a set of different nodes. Each node is having a defined, a power, its capability in the form of the processing, in the form of storing. So clients can connect to this cluster. So this is just an overview, and you can see on the figure on the screen we have the architecture here, where we have systems are connected together and they are also forming a cluster. And also we are now out of the client server environment, where only one machine is actually responsible for taking the queries of all the users, but here all the machines are actually playing a role to solve the user request by dividing the task into several tasks and then solving it all together to solve the entire problem. This is how the distributed computing is working. So let us talk about the benefit of this kind of architecture or distributed computing. So basically there are four things that we see as advantage of distributed computing. One is performance, cost effectiveness, flexibility and reliability. So when we say performance, so performance is basically is going to improve as a large task is distributed over multiple node, which works in collaboration to complete the overall task. When we say cost effectiveness as a benefit, that means the cost effectiveness is increased in the distributed computing, as most of the cases it is cheaper to scale out. Scale out means adding more nodes to the computer cluster than to scale up, that is buying or renting the additional hardware. So here we have a capability to scale up, to scale out very easily. That means we can share the resources among together to take a larger task instead of adding a new node to increase its capacity. Then we have flexibility is also one of the important benefit. So flexibility, it actually depending on the business need, the computational power, you can say, can be enhanced as and when required. This is the flexibility that we can see in the distributed computing. That is also indirectly affecting the cost effectiveness, as we have discussed in the previous point. And moreover, the computers located at different geographical areas can be used to complete the task, because the entire system is distributed where the nodes are located in the different geographical regions. So they can be used, these nodes, to get their work done based on the requirement and the location. Then we have reliability. So reliability, I mean that if you talk about centralized system, in the centralized system, the centralized server is basically a bottleneck, and the entire system may be corrupt, or the entire system may be collapse, or the system may be halt if there is a problem in the centralized server. But in the distributed system, if any of the node is getting corrupted or getting failed, then the entire system is not going to stop. It will not malfunction the entire system. So this is the beauty of the distributed computing, that it will give a fault tolerance, that if any of the node is getting corrupted during the running time, then still the system will keep on working. So these are the benefits of distributed computing, and these are the benefits we have taken, and we are using the same benefits in the cloud computing as well. Now if you look to the cloud architecture, we call it as a transformative technology because it has changed the business we do in the present scenario. So in this architecture, you can see, as shown in the diagram, the cloud infrastructure is characterized by a high-speed network. The entire cloud system is based on internet. Means if there is no internet, then we cannot imagine this architecture, because the data has to be placed at different locations, and this data can be accessed and processed only through the internet. So the entire infrastructure is actually based on the high-speed network, the storage devices, servers with a very high performance, and they are placed at different locations as a cloud data centers. Servers basically here are multiple virtual machines that are hosted on a physical machine. Now end users or the users of this cloud, they connect to the cloud through the internet using their dedicated machines or mobile devices. So this is a general idea of the cloud architecture. Thank you very much.